Hello everyone. In this video, we're going to learn about the polynomial functions and behavior. Alright, so we have four types of polynomial functions and behavior. Now the first one, we're going to talk about the leading coefficient is positive and the function has an odd degree. Alright, so in this situation, I'm going to give you an example. For example, y equals 3s cubed plus 2s. Alright, so you're going to look at the leading coefficient right here. This could be 3. This is positive, right? And the highest degree right here is 3. This is odd, right? So if you see the function like this, and then end behavior looks like this. Alright, so you see that when s approaches negative infinity, the function keeps going down to negative infinity. So make sure when you work on the end behavior of the polynomial function, make sure you need to write this one negative infinity, this one is positive infinity, this one is negative infinity, and this one is positive infinity. Right, so when s going to negative infinity, the function is going down to negative infinity. So you're going to write left behavior as the value of s decreasing without bound. The y value decreasing without bound. So you're going to say limit of the function f of s when s approaches negative infinity equals negative infinity. Alright, now the right behavior is going to be the same. Alright, so when s approaches positive infinity, the function approaches positive infinity, right? S going to the right, the functions keep going up, right? So you're going to say as the value of s increasing without bound, the y value increasing without bound, and you need to say limit of the function f of s when s approaches infinity equals infinity, right? Now we finished the first case. Now we're going to move on to the second case right here. If the leading coefficient is negative and the function still odd degree, you just flip this one right here, alright? You just flip it, it becomes upside down, so it could be like this. Alright, so it looks like this. Alright, so left behavior, when s approaches negative infinity, the function keeps going up, right? So s approaches negative infinity, but the function approaches positive infinity. So you need to say as the s values decreasing without bound, the y value increasing without bound. Saying limit of the function f of s when s approaches negative infinity, the function approaches positive infinity. Alright, the right behavior, you do exactly the same thing. Alright, when s approaches positive infinity, the function approaches negative infinity. In this situation, I just flip the sign right here. This guy becomes negative 3, and then it's going to be like this. Right? Now let's move on to the third case. The third case, we're going to talk about the leading coefficient is positive and the function has even degree. Alright, so in this situation, for example, you have y equals 2s power of 6 plus 5s power of 3. Alright, so don't worry about this guy, right? You only worry about this. The leading coefficient right here, 2, is positive, right? And then the highest degree right here, 6, this is even, right? So if you see the leading coefficient is positive and the degree is even, the function has the same end behavior. Look, the left behavior and the right behavior pointing up, right? So in this situation, you're going to say as the s value decreasing without bound, the function increasing without bound. Right, same thing on the right hand side. As the s values increasing without bound. The function increasing without bound. And then you need to say limit of the function f of s when s approaches negative infinity equals positive infinity. And limit of the function f of s when s approaches positive infinity equals positive infinity. Alright, and the last case we're going to talk about the leading coefficient is negative. And the function has an even degree. Alright, so in this situation, you just change the sign of this guy right here. And then things becomes different, right? The leading coefficient right here is going to be negative, right? So it's no more positive. And then the degree is still even, right? So this guy and this guy have the same behavior. Now for that behavior, you need to say as value of s decreasing without bound. The function decreasing without bound. Alright, same thing on the right hand side. When s increasing without bound, the function decreasing without bound. And you should be able to know how to read this one, right? Limit of the function f of s when s approaches negative infinity equals negative infinity. And the function of f of s when s approaches positive infinity is negative infinity, right? Now let's take a look at an example. For example, if I have f of s equals 6s power 7. Alright, now I'm going to ask you to determine the end behavior of this polynomial. Alright, so you need to say left behavior, right? So you need to say limit of the function f of s when s approaches. Now you look at this one, positive leading coefficient and an odd degree, right? Positive leading coefficient and odd degree, we use this case right here, right? So limit of the function f of s when s approaches negative infinity is negative infinity. And right behavior, limit of the function f of s when s approaches positive infinity is positive infinity, right? Now let's take a look at the second example. For example, if I have the function g of s is 3 over 4 s power 8 minus 2 s power 3 plus s, right? So I don't care about this guy, right? I only care about this guy right here and this guy right here. I see that leading coefficient is positive, and then this one is even degree. So we're going to use this case right here, right? Alright, so we have limit of the function g of s when s approaches negative infinity. It's going to be positive infinity, and this is left behavior. Now right behavior, left which means negative infinity, right which means positive infinity, right? Limit of the function g of s when s approaches positive infinity is going to be positive infinity. Now let's take a look at the next example. For example, if I have function g of s is 1 over 5 s power of 8 minus 2 s power of 7 plus s power of 2, something like this. Now I don't care about this guy, right? I only care about this guy right here. The leading coefficient is positive and we have the even degree right here. So we're going to look at this case right here, right? So the left behavior, we have limit of the function g of s when s approaches negative infinity, right? Equals positive infinity, right? Right here. And the right behavior, limit of the function g of s when s approaches positive infinitive equals positive infinitive, which is the one right here, right? Now let's take a look at the next example. For example, I have a function k of s is negative 3 over 5 parenthesis s minus 20 24 power 20 24, right? So I look at this one, I see that the leading coefficient right here is going to be negative, right? And then the power right here is going to be even, right? So leading coefficient is negative and even degree. We're going to look at this one right here. Alright, so left behavior, limit of the function k of s when s approaches negative infinitive is negative infinitive. Right behavior, limit of the function k of s when s approaches positive infinitive is negative infinitive, right? This guy right here and this guy right here. Now let's take a look at another example. For example, if I have a function h of s is 20 24 minus s power 2, right? So I look at this one, I see that the terms of the polynomials not written in the order, right? So I need to rewrite this one a little bit. So I need to rewrite negative s squared plus 20 24. If you don't see anything, you just put 1 right here. So leading coefficient is negative 1. And then the even degree right here, 2, right? So we're going to use this case right here, right? So we have the left behavior, limit of the function h of s when s approaches negative infinitive is negative infinitive, and right behavior, limit of the function h of s when s approaches positive infinitive is negative infinitive. Now let's take a look at another example. For example, if I have the function f of s is 3s cubed minus 4 minus s power of 5, right? So I look at this one, I see that the terms not written in the order, right? So I need to rewrite this one, right? So it could be negative s to the power of 5 plus 3s to the power of 3 minus 4, right? And then I see that the leading coefficient right here should be negative 1, right? So this leading coefficient is negative and this is odd power. So we're going to use this one right here, right? So the left behavior is going to be limit of the function f of s when s approaches negative infinitive is going to be positive infinitive. The right behavior, limit of the function f of s when s approaches positive infinitive is negative infinitive, right? Let's take a look at the next example. For example, if I have a function k of s is 3s times s minus 2 times 3 minus s, right? Now, first I need to multiply this one out, but I don't need to multiply this one out completely, right? I just look at this one, I see that s right here, and this is negative s, right? So this guy turned out to be negative s cubed, right? When you multiply this one out, it should be negative s cubed, right? And I look at this one, I see that the leading coefficient is negative, right? And then this is odd degree, right? So I look at this one, leading coefficient is negative and odd degree, I use this one, right? So I have left behavior is going to be limit of the function k of s when s approaches negative infinitive is going to be positive infinitive, right? This guy right here. And the right behavior, limit of the function k of s when s approaches positive infinitive is negative infinitive. Now let's move on to the next example. So for example, if you given left behavior, it's going to be limit of the function f of s when s approaches negative infinitive is negative infinitive, and right behavior, limit of the function f of s when s approaches positive infinitive is positive infinitive. Just get the x and y coordinate plane, right? So you need to label this is y, this is s, right? And the next step you need to write is this is positive infinitive, this is positive infinitive, this is negative infinitive, and this is negative infinitive. Alright, so you look at the left behavior right here. When s approaches negative infinitive, the function going down negative infinitive. So the function should be something like this right here, right? Because this is negative infinitive and this guy negative infinitive, right? Limit of the function f when s approaches positive infinitive, right? S approaches positive infinitive, the function approaches positive infinitive, right? So the at the end behavior should be something like this, right? So right here it could be the cubic function or the polynomial function with degree 5, 7, 9 or something like that, right? So in the middle right here it could be something like this, right? So the answers varies. Let's move on to the next example. So for example, if you given the left behavior, limit of the function f of s when s approaches negative infinitive is positive infinitive, and limit of the function f of s when s approaches positive infinitive is positive infinitive, right? So this is left behavior and this is right behavior, right? If you want to know left behavior or right behavior, look at this one right here. When s approaches negative infinitive, which means left behavior. When s approaches positive infinitive, this is right behavior, right? Now you just draw the x and y coordinate plane right here, okay? And you label the y-axis, the x-axis right here. Alright, next one you just put positive infinitive right here. This one positive infinitive, this is negative infinitive, and this is negative infinitive, right? So look at this one. When s approaches negative infinitive, which means s going this way, and then the function approaches positive infinitive, which means y is going this way, right? So I know that my left behavior should be something like this, right? Okay, now the right behavior, when s approaches positive infinitive, which means s going this way, and then the function approaches positive infinitive, which means y going up, right? So the right behavior should be something like this, right? Now in the middle right here could be something, right? The answer vary. It could be s squared, it could be s power 4, it could be s power 6, 8, 10, 12 or 20, 24, something like that, right? So the answer right here I could draw it like this. Something like that, right? Let's take a look at another example. So for example, if you given the left behavior, limit of the function f of s when s approaches negative infinitive is going to be positive infinitive, and you have right behavior, it's going to be limit of the function f of s when s approaches positive infinitive is going to be negative infinitive, right? So how do you sketch this one? So you just have x and y coordinate plane right here, label s and y, right? Now put positive infinitive right here, positive infinitive, negative infinitive, and negative infinitive, right? So you look at the first one right here. When s approaches negative infinitive, right, the function approaches positive infinitive, right? So when s going this way, the function going up, right? So you have the first one is going to be something like this, right? Second one, when s approaches positive infinitive, the function approaches negative infinitive, which means going down like this, right? So you have something like this, right? So in the middle right here, you can draw something else, right? It could be s cubed, s to the 5th, s to the 7th, s to the 25th, something like that, right? So the answers vary, so I could draw something like this. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.